welcome. This week we have been building Bayesian networks for medical diagnosis. Bayesian networks majorly uses Bayes' theorem to model dependencies and causal relationship between variables. And majorly they learn as evidence build up, and this week we were majorly dealing with that, and we were using PGMPI to build the model, and I use Clever and Art Data to build a model. And actually we load the data, did some sanity checks, worked on the variable, at least on various variables and labels, at least to make them understandable. Did some exploratory data analysis, univariate and bivariate, and majorly our target variable condition was balanced. And after that we encoded and constructed the Bayesian network. And the Bayesian network, our structure, we did not incorporate all the variables to reduce computational complexity associated by RAM allocation by column. And in this case, we from PGMPI, we used this discrete Bayesian network and build the model. For that we visualize the model, the nodes, the edges, and actually we performed the inference using variable elimination, and we were able to compare posterior probabilities, and even we were able to look at the marginal probability distributions. We did some model evaluation, and actually we made a prediction, and generally the insights from the analysis we have built discrete Bayesian network model using PGMPI with models nodes, age, condition, called large sex male, and also the ages. And majorly we assumed conditional independence between variables, which majorly is not the case. Mostly you will find the variables are interrelated. Then the model was able to infer, especially for example, when evidence was sex, then the sex was male, and the FBS variable was lower, respectively, resulted in equal probabilities for both conditions, with slight leaning towards condition 0, which had posterior probability of 0.5001. And when we compared an evidence of several variables, it was able to provide marginal probability distributions with the two states having equal probability, equal chance of occurrence. The model performed well in terms of both accuracy, precision, recall, and F-score at 100%, though presenting higher chances of overfitting and unable to learn the pattern going by almost similar posterior probability. This model had the limitation, especially since we constructed the network manually. We manually defined it with limited prior knowledge. Hence, we were not able to capture the complex relationship between various variables. Also, has a limitation, like especially understanding complex interactions and conditional dependency might be difficult to understand by the users. You also noted that we use discrete Bayesian network due to the version we were using had depreciated several dependency, and therefore we used the discrete Bayesian network, and you noted that even continuous variables like age all were incorporated in the same, so that is a limitation. Then ethical concern, especially with the model, it may exhibit bias in prediction, since we noted that there was some variables were not representative, especially sex, where male were dominant, and age, where not all ages were represented. This can lead disparities in diagnosis. Also, relying on the model to undertake diagnosis might erode patients' trust, since the model uses sensitive patients' data, and therefore there is privacy concerns. Thank you.